Without water, the diversity of life as we know it would not exist. Life that makes the Earth so unique and which makes our existence possible. But the supply of life-giving water is under threat. Groundwater levels have dropped severely in many regions because of overexploitation. The global water balance is also influenced by climate change. The ice in the polar regions is melting, causing sea levels to rise. That is why we must know how the valuable water is distributed on the Earth. To observe this, scientists would have to drill wells everywhere and put up measuring stations, which is impossible and would be far too expensive.
Satellite gravity missions are the only way to monitor the mass distribution and the change of the mass distribution of the whole Earth.
Water is mass, and mass distribution can be observed with the satellites of the GRACE follow-on mission. They circle the Earth 15 times a day to measure its gravity field, continuing the work done by their predecessors, the GRACE satellites.
It is very important, as the name says, GRACE follow-on, to continue the GRACE-derived time series over another 5-10 years to get statistically reliable observations for climate research studies.
In addition to microwave distance measuring equipment to chart the gravitational field, the satellites also have the next generation technology on board, a laser interferometer developed by geo-Q.
geo-Q is a group of scientists from various disciplines that are coming together to research new ways to learn something about the Earth. And we are developing and adapting new methods that are from fundamental physics, change them so that they can be used for geodesy and for observing the Earth environment.
The laser interferometer is taken from the field of astrophysics and can measure distance more precisely than ever before.
Rock steady.
This observation method was developed to open a new window on the universe by detecting gravitational waves in space in the near future.
No, it's still clean.
The system was already successfully demonstrated in a single satellite during the LISA Pathfinder mission. The interferometer now has to prove that it will also work between two separate satellites. geo-Q scientists had to develop new technologies to achieve this. These can now be tested in space for the first time.
We will analyze the data from GRACE follow-on and in particular of the laser ranging interferometer, and will try to understand its behavior in orbit, and then we'll take the experience that we get from there to design the next generation of instruments for the next generation of missions, which presumably will use only laser interferometry and not microwave anymore, assuming that the LRI works as we hope it does.
The new laser system is able to measure the distance between the two satellites more than 10 times more precisely than microwave technology. This allows scientists to derive the shape of the Earth's gravitational field more precisely. The satellites fly in a trailing formation. Depending on the mass passing below them, they experience different gravitational attractions. These differences cause small changes in the distance between the satellites. Because they fly over every point on the Earth several times, they can spot changes in mass, like those taking place in the polar ice caps due to melting, or the changes in groundwater levels. Each month, the satellites deliver a snapshot of the Earth's gravity field. With this data, geoscientists can determine how the global water balance evolves. They're able to see how water is distributed underground and on the Earth's surface, and how it moves around with the changing seasons.
The Danube Basin, with a size of roughly 800,000 square kilometers, this is what we can see now with GRACE. But it's so large that we would be interested in getting information within the basin itself, so for different sub-basins. And this is what we hopefully get from next generation gravity field missions.
Scientists will better examine how groundwater storage changes with heavy rainfalls, enabling them to estimate the likelihood of flooding, and also the danger from rising sea levels. The laser system from geo-Q will soon help to make this possible.
Space and time are affected by velocities and by nearby masses, and now we want to make space and time measurements in order to derive from these time measurements the mass distribution.
To do this, we need to measure gravity with clocks. Stay tuned to learn how this works.